Let's actually look at an example of using variation of parameters. So here is a second-order linear differential equation, and it's not homogeneous, right? The right-hand side is tangent. And remember, tangent is a function for an inhomogeneous term in a differential equation. Tangent is an example of an inhomogeneous term where undetermined coefficients will not work, right? Because if you start taking derivatives of tangent to figure out what your guess should be for undetermined coefficients, you get an infinitely long chain of derivatives that never loops back on itself. So undetermined coefficients won't work here. So we need to do something else, and something else is variation of parameters, right? For variation of parameters, first thing we need to do is find a fundamental set of solutions to the associated homogeneous equation. So the associated homogeneous equation is y double prime plus y equals 0. You might know solutions to this right off the top of your head, but just in case you don't, the characteristic equation is m squared plus 1 equals 0. So we get m equals plus or minus I, and that means solutions for our fundamental set are sine x and cosine x. Okay, now that we have a fundamental set of solutions, we can use our formulas to find u1 and u2. Remember, in variation of parameters, our particular solution is going to take the form u1 y1 plus u2 y2. And we have formulas for these functions u1 and u2, but that formula involves the Wronskian, so we're going to have to calculate the Wronskian of these y1 and y2. So that's the determinant of y1, which is sine x, y2, which is cosine x, y1 prime, which is cosine x, and y2 prime, which is minus sine x. And this turns out to be minus sine squared x minus cosine squared x, and that's minus 1. Okay, now we can use the formula for u1 prime and u2 prime. So u1 prime is minus y2 f over the Wronskian. So minus y2 is cosine. F, remember, f is the inhomogeneous term, so that's the right-hand side of the original differential equation. And for us, that was tangent. And the Wronskian is minus 1. So cosine times tangent is sine. These minus signs cancel each other, so we just get sine for u1 prime. So then we can integrate this to get u1. u1 is minus cosine plus a constant. But remember, we just need an example of u1. We don't need a general form for u1, so we can take this constant to be 0 if we want. Okay, now for u2, u2 prime is y1 f over the Wronskian. So this is y1 is sine x, f is tangent, and the Wronskian is minus 1. So we're going to get, looks like minus sine x times tangent x is sine squared x over cosine. All right, so now we need to figure out how to integrate this guy. One thing you can do is having a mix of sines in the numerators and cosines in the denominator is kind of troublesome, but we can make everything cosines if we replace sine squared with 1 minus cosine squared. Okay, let's use this minus sign to turn the sum in the numerator around, or the difference. So we get cosine squared x minus 1 over cosine x. And then we can split up this fraction. So cosine squared over cosine is cosine x minus, and then 1 over cosine is secant x. And then this is something that we can integrate. So u2, when we integrate, so integral of cosine is sine, and integral of secant is natural log absolute value secant x plus tangent x. I think I have that right. Yeah. Plus a constant, but remember, we just are looking for an example of u2. We don't need the general form for u sub 2, so we can make that constant 0. Okay, now that we have u1 and u2, we can form our particular solution. So it's u1 y1 plus u2 y2. u1 up here was minus cosine times y1, which was sine x, plus u2, which is sine x, minus natural log absolute value secant x plus tangent x, times y2, which is cosine x. And there we go. There's a particular solution. Now for a general solution, of course, you take the particular solution, so this whole mess, I won't write it out again, plus the complementary solution, which as always is c1y1, so c1 sine x plus c2 cosine x. And there we go. We found the general solution for an inhomogeneous linear equation that we couldn't solve using undetermined coefficients.